Hello everyone, this is Kriti Mishra, lecturer, Department of Electrical Engineering, IIMT College of Polytechnic, Greater Noida. So today we are going to discuss about transformer. So basically, what is transformer? Can you define transformer as a machine or a device? So here we are giving some small definition of transformer. So electrical power transformer is a static device. It is not machine. It's a device because machine is generally having rotating part generators and motors, but in transformer it does not have any rotating part. It is a static device which transform electrical energy from one circuit to another without any direct electrical connection. So, from how we can transform electrical energy from one circuit to another without any direct electrical connection with the help of mutual induction. With the help of mutual induction, we are transforming electrical energy from one circuit to another without any electrical connection between the two windings. It transforms power from one circuit to another without changing its frequency, but maybe in different voltage level. So what transformer does is basically changing the voltage level from higher voltage level to the lower, or from lower voltage to the higher level, from one circuit to another. So it transforms power from one circuit to another without changing its frequency. Frequency remains constant, and but maybe in different voltage level. So here we are going to discuss about working principle of transformer, how it transform one how it transform power from one winding to the another without any direct connection. What are the basic principles? What are the basic working principles of transformer through which this transformation is being done? So the working principle of transformer is very simple. It depends upon Faraday's law of electromagnetic induction. So electromagnetic induction will help us to transform energy from one circuit to another. Between two or more winding, mutual induction between two or more winding is responsible for transformation action in an electrical transformer. Faraday's law of electromagnetic induction. What does Faraday's law of electromagnetic induction says? It says that rate of change of flux linkage uh, from the primary winding, when we are supplying power from primary winding, some flux will generate in the primary winding. So the rate of change of that flux linkage with respect to time is directly proportional to the induced EMF in a conductor or coil. So what do you mean by linkage, and what do you mean by flux linkage? And so we are going to discuss in the next slide. Another slide. So basic theory of transformer is primary winding which is supplied by electrical source. Transformer consists of primary winding, secondary winding, and core. So primary winding is that winding which is being supplied by electrical source, and the secondary winding is brought secondary winding is that part through which the output we are produced. What output we have produced is taken by secondary winding. The alternating current through the primary winding produces a continually changing flux or alternating flux that surrounds the winding. So the alternating current through the primary winding produces a continually changing flux. That continually changing flux is rate of change of flux. When it will link with the secondary, it will produce an induced EMF. So the next point is, if any other secondary winding is brought near to the previous one, obviously some portion, in the next slide we can see this one is the primary winding and this one is the secondary winding. When we have supplied V1, in this winding, these flux will generated in the primary winding, and it will link up with the secondary coil. It will link up with the secondary coil. This is known as flux linkage, what I have told in your previous slides that I'll explain later. So this is called as flux linking from the primary to the secondary. So if any other secondary winding, when the secondary coil is brought nearer to the first coil or primary coil, the flux linking will be more. When we put apart the secondary winding or put apart far distance, if we have made some distance longer, then we see that the primary winding and the secondary winding will have some lesser flux linking. So when we put these winding closer, the flux linking is maximum. So the maximum voltage is induced, that is V2, is induced in the secondary winding. This is all about the Faraday's law of electromagnetic induction. If any other secondary winding is brought nearer to the previous one, obviously some portion of this flux will link with the second, and as this flux is continually changing it in its amplitude and direction, there must be a change in flux linkage in the secondary winding or coil. Through this diagram, we can easily understand what this Faraday's law of electromagnetic is explaining. There must be an EMF induced in the second. If the circuit of the secondary winding is closed, there must be a current flowing through it. So this is the basic concepts of basic working principle of transformer. Next, the winding which takes electrical power from the source is generally known as primary. This V1, we can see in this picture, that's V1 is connected to the first coil. So this winding is what we call this winding is primary winding. Okay. Next is the secondary coil. The winding which gives the desired output voltage due to mutual induction. The flux linking, that is mutual induction. The winding which gives the desired output voltage due to mutual induction in transformer is commonly known as secondary. So we are getting our desired output from V2. So the second coil is the secondary coil. The above mentioned means this figure, the above mentioned form of transformer is theoretically possible but not practically. Because why it is not practically possible? Because in open air, very tiny portion of the flux of primary winding will link with the secondary. Linking is the major sub part or the mediocre for primary winding to link with the secondary one. Like it transform that power from primary to secondary, right? So the current that flow from the closed circuit of the secondary will be so small in amount that it will be difficult to measure. Why it is difficult to measure? Because the current is so small and we don't have that much of emitter to measure that amount of current. So the above mentioned form of transformer is theoretically not possible because in open air or air medium here, if open air is a medium for primary winding, for transferring its flux to the secondary or linking its primary flux to the secondary, very tiny portion of the flux will link with the secondary, as mostly all the flux will be leakaged. It will not linking up with the secondary winding. It will get leaked. So the rate of change of flux linkage depends upon the amount of linked flux, right? The rate of change of flux linkage depends upon the amount of flux linked with the secondary winding. So it is desired to be linked to almost all the flux of primary to the secondary winding. Means if all the primary winding flux is linked with the secondary winding, means leakage is very small, right? Like losses and the output what we are getting is you can imagine as the flux linking and the leakage, right? The losses are the leakage one and the output is the linked one. So it is desired to link to almost all the flux of primary winding to the secondary winding. This is effectively and efficiently done by placing one low reluctance path common to both the winding. What is reluctance? Like in electrical field, resistance is providing the opposition to the electric current. Likewise, in magnetic field, we have reluctance. So here we have some low reluctance path which can easily pass the flux to from primary to the secondary. So we need efficient method or efficient material of low reluctance path common to both the windings. So what is that low reluctance path of material? This is core of transformer. This low reluctance path is core of transformer. Uh, we can see this picture, that air is a medium for primary and secondary linking. And in this slide, we have a core for which links primary flux to the secondary, which links primary flux to the secondary and have minimum leakage You can see this portion is having minimum leakage. This is the leakage part and all are linking parts, flux linking. This low reluctance path is core of transformer through which maximum number of flux produced by the primary is passed through and linked with the secondary winding. Here we can see the leakage flux which are not linking up with the secondary, is present in primary but not linking with up the secondary. Okay. Next, main constructional parts of transformer. The three main parts of transformer are, as we already discussed, primary winding of transformer, which produces magnetic flux when it is connected to electrical source. The next one is magnetic core of transformer, the magnetic flux produced by the primary winding that will pass through this low reluctance path linked with the secondary winding create a closed magnetic circuit. We can see here secondary winding of transformer. Secondary winding of transformer, the flux produced by primary winding passes through the core, will link the secondary winding. This winding also bounds on the same core and gives the desired output of the transformer. These are some basics of transformer which you need to understand when we learn machines in electrical engineering. Next slide is all about the real images of winding cores and industries, what we are going to see. This is the winding work of the transformer, winding job of the transformer. You can generally see in Alstom where large transformers are made or power transformers are made. Next one is core building. Core of the transformer. Here we can put windings over them. View of core structure after completion of core lamination. Here we are going to see coil insertion work of windings. These are the view of core and coil assembly works. These are the practical work which you can see or learn in the sections. You can practically see in Alstom and Bale. This is the VPD, generally drying works in vacuum vaporization facility. This will remove the vapors from all the transformers, windings, insulations, oils, everything which we have made. If there is little bit of moisture there, it will remove through this vacuum vaporization facility. Thank you. Have a nice day.